In this last video, we're going to solve some logarithmic equations that are a little bit more complicated. Here we have natural log of x minus 2 plus natural log of 2x minus 3 equals 2 times natural log of x. What I'm going to start with is condensing the left-hand side and making it a little bit more simpler. So we're going to condense that left-hand side. That's going to give us the natural log of x minus 2 times 2x minus 3 equals 2 times the natural log of x. Now remember that the two binomials being multiplied together are in the same argument. The left-hand side, I'm going to keep this still, x minus 2 times 2x minus 3. And I'm going to make the right-hand side natural log of x squared. And when you have log base a of x equals log base a of y, remember this property, then x equals y. Then the arguments have to equal each other. So when you have one logarithm equals one logarithm, and those two logarithms have the same base, then the arguments are equal. So we have x minus 2 times 2x minus 3 equals x squared. I'm going to FOIL out the left-hand side. 2x squared minus 7x plus 6 equals x squared. We'll set this equation equal to 0 by subtracting x squared from both sides. And then we're going to factor and use our zero product property. X squared minus 7x plus 6 factors to be x minus 1, x minus 6. So our two values for x are 1 and 6. However, we need to go back to the original equation. So we have to go back to this original equation and make sure that neither solution makes the argument less than 0. So or less than or equal to 0. So we have to remain positive in the argument. So remember, the argument has to be greater than 0. So we're going to put a 1 in. I'm going to rewrite natural log of x minus 2 plus natural log of 2x minus 3 equals 2 times the natural log of x. So I go back to the original, and I'm going to put a 1 in, and I'm going to see if this 1 makes any of the logarithms invalid. So when I put 1 in to the very first term, 1 minus 2 is negative 1. Natural log of negative 1 does not exist. Therefore, 1 is an extraneous solution. So I'm going to write that. X equals 1 is extraneous. So now I'm hoping that 6 is going to work. So we're going to try for 6. So we're going to see if we can put a 6 in to each logarithm and keep all of the arguments positive. 6 minus 2, that's 4, that's positive, so it works in the first term. We go to the next term. 2 times 6 is 12. 12 minus 3 is positive, it's 9. And we put a 6 in the last one. Natural log of 6, 6 is positive. Therefore, 6 is the solution. So x equals 6 is the only solution. However, x equals 1 is extraneous, is additional information. So when we're solving logarithmic equations, we always have to check to make sure our solution is going to make the original equation valid. Okay, let's try one for you. So you go ahead and try this one. Press pause, and when you're ready to come back, I will reveal the answer and the work. Okay, welcome back. We've got when I multiply this together, I've got x times x plus 2 equals x plus 6. So you should have that in your work. If you're wondering where that came from, I should probably show you. Log base 2 of x times x plus 2 equals log base 2 of x plus 6. And then 1 logarithm equals 1 logarithm with the same bases. Therefore, the argument equals the argument. So we've got x squared plus 2x equals x plus 6. That's going to give us x squared plus x minus 6 equals 0. And you should have factored this to be x plus 3, x minus 2 equals 0. So we're going to check for negative 3 and positive 2. If we put a negative 3 in, as soon as we put it into the first term, it invalidates it. X equals negative 3 is extraneous. And then the next value, x equals 2, that's going to work. X equals 2, 2 is positive. I'm going to go right through my work here. 2 plus 2 is 4, that's positive. And 2 plus 6 is 8, that's positive. So 2 is going to work. So x equals 2 is our solution, and that's what gets boxed. Okay, I want to try one more with you. So create another page here. And this is an example, just in case this comes up, which I'm sure it will. It's a good problem. Log base 2 of x minus log base 2 of x plus 5 equals 3. So this problem, I don't have logarithms on both sides, but that's okay because I'm still going to take this left-hand side and I'm going to condense it. But this time, instead of being a product of the arguments, it's log base 2 of the quotient. So x is in the numerator and x plus 5 is in the denominator. So when I condense this, it becomes an argument that has a quotient. And then I'm now going to put this into exponential form. So now we're going to write it in exponential form. So we're using a different property here. I can't use this property. This property just does not apply right now because I don't have a logarithm on the right-hand side of the equation. So I don't have a logarithm equals a logarithm. So I'm going to have to go to exponential form. So exponential form says the base raised to the exponent equals the argument. So the base of 2 raised to the exponent is equal to the argument. And 2 cubed is 8. So we have 8 equals x over x plus 5. If I put 8 over 1, I can cross multiply. 8 times all of x plus 5 is 8x plus 40 equals x. I'm going to subtract 8x, and I get 40 equals negative 7x, and then divide both sides by negative 7. X equals negative 40 over 7. Remember, even though there's only one solution, I still have to check it to make sure that it's going to work in the original problem. If I take this negative 40 over 7 and I put it into any of the logarithms, and it creates a negative argument, or even it could create a 0 argument. Those would both be invalid, giving you an extraneous solution. So negative 40 over 7 in the argument in this very first term right here causes a problem. So x equals negative 40 over 7 is extraneous, and there's no other solution to box. Therefore, x equals no solution. So no solution. So if you come across a problem like that where you have logarithms equals a constant, we need to remember to use that exponential form. So let's make sure that we are good. Approximate the solution of natural log of x equals x squared minus 2. Very quickly here, I'm not even going to put this into the calculator. There's two things that you can do. You can set the equation equal to 0, natural log of x, where x is the argument, minus x squared plus 2 equals 0. You could also say x squared minus 2 minus natural log of x equals 0. So you could bring everything over to the right-hand side. Put this in for y1 and find your roots. Sometimes solving with your calculator can be really tricky because the location of the root or the location of the intersection point is really difficult for the calculator to find. So it sometimes takes a long time. So if your calculator is thinking and thinking and thinking, just go ahead and let it think and everything will be okay. There's another way that you can solve this, and that's natural log of x equals x squared minus 2. Let the left-hand side be y1, and let the right-hand side be y2, and then use the intersect. And when you use the intersect, it's going to be the x value of that intersection point that is the solution. So that's how you would go about using your graphing utility to solve an equation that would be extremely difficult, if not impossible, for us at our level to solve by hand. This would be pretty difficult for us to solve this by hand. So I hope that you enjoyed this series of lessons and that it helps you work on those homework problems. Thanks for listening.